All right, TC Honors Bio, this is the presentation for Cladograms. This will help you with the two assignments this week. If you have your textbook, I think it's 18-2, but at this point, just kind of follow along. You also have access to it in Google Classroom. And so when we talk about cladogram, this just shows how organisms branch off of a common ancestor. And so a cladogram is made of clades. Think of a clade as like a group. And so if you look here on the PowerPoint, this green, all of that's a clade. This one by itself is a clade, not a clade, not a clade. The key is that the clade has to include the common ancestor. So a cladogram is made of clades, and a clade is a group of species that includes a single common ancestor and all its descendants. What we would have done in class is we would have had, these are pipe cleaners. So I have 2, 4, 6, I have 8 different colors of pipe cleaners. At the bottom, if I twist these pipe cleaners together, right, this would represent a common ancestor. And then over time, something may happen, and this green one may branch off. So there was a change in the environment, and now this one, for whatever reason, this green one is all off by itself. And so it's a clade by itself. These groups, they're continuing together, and then some kind of change in the environment occurs, and this black and the yellow one, for whatever reason, they branch off, right? They're on their own, and then eventually they're going to branch off. And now we've got a green clade, and this is kind of tough to see on here. We've got the black and the yellow. This is a clade. These continue to kind of have a common ancestor. Changing environment occurs, and now this purple one, for whatever reason, will branch off, right? So some kind of changing environment. These ones continue to evolve together for whatever reason, now changing environment, but then the red and the blue kind of branch off from everybody else. Let me twist them. I know this is kind of tough to see. So now we've got the red and the blue. Right, I don't know if you guys can see that. We've got the red and the blue, they're their own clade. And then these two keep twisting and twisting and twisting, and then eventually they split off into their own respective groups. So this is a pipe cleaner cladogram. We would have done this in class. But each one of these separate, this is a clade, this is a clade, orange and white are a clade, yellow and black are a clade, green by itself is a clade. All of this together is a single cladogram. And so it's a little better when we do it in class, but so when we build a reading a cladogram, you draw the picture in your notes and label it if you want. You don't have to. So these are the descendants, 1, 2, 3, 4. Here's the ancestor, which would be down here at the base, right? This would be the past. This would be the recent, right? The roots of the tree are the ancestors, and these branches, these are all the descendants. And so as you go from the bottom up, you're moving forward in time. And so, again, if you want to draw this in your notes, you don't have to, but this is a speciation event. So something happened here in the environment where this group, right, it's called speciation, branched off to form its own group. Everything was good, speciation event occurred, the black and the yellow branched off. So each one of these little branches represents a speciation event. So as they branch off. So when you build it, a cladogram indicates degree of relatedness among organisms. The past is at the bottom. So if we look at this, which species are more closely related to each other? 3 and 4 are, because if you look, here's their most recent common ancestor. They branched off. So if we look at my cladogram, it's going to be the ones that are probably the most closely related are my orange and white, because they've diverged most recently. So if you build it, right, which species are more closely related, A and B or B and C? So here's A, then here's B and C. Over here, this would represent, so actually, which species are more closely related are B and C, because here's a common ancestor, speciation event, common ancestor, speciation event. So the cladogram represents current hypothesis about evolutionary relation among vertebrates. So we've got sharks, rays, amphibians, turtles. lizards, snakes, crocodiles, birds, mammals. Amphibians are more closely related to, so we look at the amphibians, right? They're more closely related to the fish than they are the turtles. They tend to be more closely related to what's below them, not above. And so if you look here, crocodiles and birds, most common recent ancestor. Lizards and snakes have a more common ancestor. But if we look at these amphibians, right, down here, right, there's their most common recent ancestor between the fish and the amphibians. Here's another example of a clade. Smaller clades are nested within larger. So we've got tetrapods, these are your four limbs, reptiles, marsupials, carnivores, and felidae are the cats. So how this works, the organism has everything below, nothing above. The frogs have four limbs. They do not have any of these other things. The marsupials have hair, amniotic sac, four limbs. They don't have any of these other things. So if you look at a cladogram, everything below, nothing above. And so here's felidae again. We talk about cats. So the last common ancestor of all four-limbed animals, and then these are the characteristics. And why are they important? Because they just show us how more recently they shared a common ancestor. And so you can even look at the DNA evidence. So if you look at this, species A through H, and all these things that are highlighted, their differences, species C and D, right, may only have one difference between them. Species E and F have 6, right? 5, 2, 4, 7. So all of these differences, these numbers refer to the DNA evidence. But the more DNA they have in common, the more closely related they are. So again, this was just a quick overview. I don't know if my pipe cleaners helped, but you kind of get the idea. Watch the video. Watch the things I showed you, the Bozeman and amoeba sisters. And like I said, we're wrapping up evolutionary biology. So this is it for the week. So if you got any questions, feel free to Zoom. And this is me signing off. A little bit of an echo in here because I'm in my upstairs office. Hopefully you have a good day.